Everybody's seen the launch of SpaceX's Starship, but what actually happened in that massive dust cloud underneath the rocket? I'm John Galloway with NSF, and not only did I look at all the videos, I made miniature replicas of the pad and sprayed them with a pressure washer in my backyard to see what might have happened. Let's hop right in and see what SpaceX may have learned and what they need to learn so the next one goes successfully. This video is sponsored by Pixel Starships. There's a ton of armchair rocket engineers who think that, maybe SpaceX shouldn't have launched, maybe they weren't ready to launch, maybe they should have waited another couple weeks or months, or maybe they just stuffed it through to get the launch on a meme-worthy date, right? But check this out. There's a little bit of credence to it. You can't build the world's most powerful rocket without dealing with the force that comes out the bottom of the world's most powerful rocket. That was a big part of what happened in the launch. Here's the deal. SpaceX hasn't built a lot of launch pad infrastructure that you normally see around launch pads. You've probably seen, like around the Cape, these man-made concrete mountains where they're trying to lift the rocket up off the ground a little bit and actually control the direction that the force coming out of the rocket goes. Called flame diverters, flame trenchers, there's lots of different things to call it, right? But it was noticeably not there for the Starship launch. Instead of having a flame director that would cause the exhaust to come out the bottom of the rocket and go in a controlled direction, SpaceX just fired it at flat concrete. Did that work out? Well, kinda yes and no. So the rocket did lift off, and the rocket did clear the tower and actually go out over the ocean. And it actually did a little bit of, flying. But then it did some things that rockets shouldn't do, like puke engine parts out the back. We've seen tons of Raptor tests out at McGregor, and Raptors seem to be, when they're on their own, pretty reliable. So why did we have so many failures on this launch? Was it just statistically there were 33 engines, so just statistically with that many engines, some are going to have problems? Or did something actually happen that caused the engines to become weak, get damaged, and fail? Let's step through a lot of the details here and see if there's any evidence we can observe that may lean us in one direction or the other. So like I said, there's no real system underneath the rocket that tries to send the exhaust in a direction. There's a Firex system it's basically like a mister at a theme park, right? It's not really going to disperse a bunch of energy. All they're really doing with this Firex system is trying to create an environment where explosions won't happen. It's a little bit of nitrogen mixed in with some misting water. Nothing like the massive deluge systems you see on NASA's SLS or even the Falcon 9 rockets at the Cape. Now, the lack of the deluge system and the lack of the flame diverter meant that SpaceX wasn't really in control of where the energy from their most powerful rocket ended up. It was bouncing straight off the flat concrete surface and going, everywhere, basically. In fact, you can actually see from all sorts of different angles massive chunks of concrete flying way higher than chunks of concrete should fly. It's not just the concrete spreading out in a footprint like a distance away from the tower, right? It's the concrete flying high into the air. There are massive pieces of concrete that reach the level of the QD arm, the quick disconnect arm that actually connects to the bottom of the ship, right? That's 70 meters off the ground. And to get a piece of concrete larger than a car to fly that high off the ground, you've got a lot of energy. You can also see even smaller pieces going even higher. Some of the smaller chunks seem to clear the top of the tower by a good margin. It's really difficult to see what was actually happening because of all the dust that gets kicked up. But is that actually dust? Was it sand? Was it pulverized concrete? That's a good question. In fact, while we were filming this video, I ran across this sort of citizen science endeavor that's headed up by Dr. Phil Metzger. Dr. Metzger is one of the world's leading experts on what rocket exhaust does to regolith, lunar soil, launch pads, that sort of stuff, right? And he actually requested that folks over in Port Isabel who experienced some of this fallout from the concrete sand cloud send him samples of the particulate that came down after the launch. And they found some really interesting stuff that you can see over on this Twitter thread. I'm going to put the link to the Twitter thread down below. But Analyzing the particles, they found two different sizes, and one hypothesis that they came up with is that maybe some of it is concrete from the pad and other parts of it are sand from underneath the pad. But they made it miles away, all the way over to Port Isabel, just the way the prevailing wind was going. And right now they're continuing to analyze this. So check out the Twitter thread, and also check out some of Dr. Metzger's other work, because there's a lot of fascinating stuff about plume impingement in lunar regolith and that sort of stuff. Moving along. You may have noticed that we've been upping our video game lately. I mean, look at the length of this video. We spent a significant amount of time on it. And we're able to do that because a lot of our videos are sponsored nowadays. Oh no, sponsored shout out. What are we going to do? Click away. Nah, hang on. I actually look at all the sponsors before we agree to have them on our channel. I saw this one. This segment of the video is sponsored by Pixel Starships. And I said, okay, space game, mobile game, pixel art. I like pixel art, right? That looks like it's good. Go ahead and allow that, right? And then I actually went, I saw the ad in our own video after the ad was ready, and I used the code NSF125, and I downloaded the game via the link, and I started playing it. And the next time we had an opportunity to do an ad for Pixel Starships, I was like, me, I want to do it. Because literally, it's on my phone. You have sort of the spaceship, and you design the rooms. Here's this room, here's that room, except it's not a fixed layout. You get to design where your own rooms are, and that's really where the game gets interesting. You get to decide, okay, my missile room needs to be here, and then my reactor needs to be here, and my little space cadet is gonna like be able to walk between these things. Then we have to install a turbo lift to get to another floor. But even if you optimize the rooms, it's not just like the room layout and then shooting at people with lasers or whatever. You can actually tell the crew and the systems what to do in a battle. So, you know, if your shield hit point is less than 50%, then this person needs to run to the shield room and try to fix it. And it's a really interesting challenge. It's not just, you know, tap to win, but it's actually, you got to think through how you're going to set stuff up. Now, the game's been around for years, but people keep playing it, and so the devs always update it with fresh content. Maybe check out Pixel Starships. I'm having a lot of fun with it. In fact, I mean, my name in game is Valdezi. You can come find me and send me a message if you find me in game. But if you want to get a little jump start with some Starbucks, download the game from the link and you'll end up with 100 free Starbucks to start. That's literally what I did. And then if you enter in the code NSF125, you'll get another 125, also what I did, that you can use to spend on crew gear or whatever. It's a good little kickstart to get you going. I thought it was interesting, thought you might enjoy it as well, and therefore it was approved as a sponsor for the channel. Let's get back to the actual starships, though. So let's dig into some details and see what may have caused not only the massive crater at the base of the Starship launch pad, but the Starship to have engines come out the back of it and do its little somersault routine before eventually being destroyed by the flight termination system. But not quite as quickly as SpaceX had hoped. So here's another important thing to understand. When SpaceX launched the Starship, they didn't just let it go as soon as the engines turned on. It's a common misconception. A lot of people think, oh, the engines are on, the rocket's going to start flying. The engines actually take a little bit of time to get ramped up, and with 33 engines on the bottom of the booster, SpaceX gave it a little bit more time to sort of ease into full power mode. What happened is the Starship was just sitting on the pad, and as the engines increased their thrust, eventually the thrust of the engines overcame the weight of the entire rocket, full stack, and that's what caused Starship to begin moving upwards. It wasn't until the Raptors throttled up that it had enough force to actually take off. Gravity was just holding it down. But that meant that Starship sat on the pad, firing its engines at concrete for longer than a rocket normally would. Why is that a big deal? Well, normally they have flame diverters or other systems to mitigate the energy that's coming out of the engines and send it in a direction, disperse it, use it up by turning water into steam or whatever, but SpaceX didn't have any of that. So the longer the Starship sat there on the pad, ramping up the engines before it took off, the more and more possibility there was for something to go wrong. In fact, in a Twitter space, Elon actually said that when the rocket lifted off, there were some engines that were intentionally not turned on. Now, normally that's not that weird, right? It's a perfectly normal thing for a rocket launch company to review the health of the rocket, including all the independent systems, like the engines, each and every engine, before they decide to take off. I mean, the entire countdown while they're fueling the rocket and chilling the rocket and all these sorts of things, they're monitoring all these systems. Are the pressures correct? Are the temperatures correct? And if there's something that's not happening, like a stuck valve, or something, they'll scrub the launch. That is not unusual. In fact, we even know that SpaceX had that hold at T-minus 40 seconds, where most likely there was some decision-making or discussions happening based on the information right up to that point. Is everything ready to go or not? What's weird about this is that even missing a couple engines, Starship still took off. Now, on a normal launch, if that happens, say a Falcon 9, right? 9 engines on the Falcon 9. If Falcon 9 is trying to send a payload into orbit and one of the engines is not healthy enough, they'll go ahead and scrub the launch in advance. They'll just say, nah, we're not going for it today. If Falcon 9 tries to take off and one of the engines isn't behaving well, the system can catch that in the milliseconds before it actually lifts off and abort everything and shut it down. That's different than what rockets which use solid motors, like SLS, some of the Atlas V's. Those things are massive fireworks. As soon as you light them, you cannot turn them back off. So you light the SRBs and you're committed to launch. If you look back at the space shuttle, you could actually see the space shuttle would turn on its Hydrolox-powered RS-25s before it actually lit the SRBs. And as they were sure that the RS-25s were nice and healthy, then they would light the main SRBs, like 80-90% of the thrust for the space shuttle at takeoff, because once those candles were lit, you're going to space today, or at least you're leaving the pad. But for Starship, with 33 engines, it didn't actually need to do that. It could take off from the pad with the thrust of only 30 engines in play. In fact, I don't even think they had them throttled up all the way. Elon had mentioned that it was something like 90% thrust that was used whenever Starship lifted off. But all that being said, when rockets normally take time to make sure that their engines are healthy, they have a system in place to deal with the energy while that happens. It's also sort of a minimum amount of time. You don't sit there for 10 seconds just running the engines before you decide to take off or not. Starship didn't have that. Starship was just firing the healthy Raptors at a flat piece of concrete down below it. To say excitement guaranteed would be an understatement. But, alright, okay, what does this actually mean? If those engines weren't on whenever the Starship took off, but that was intentional, that means that the first 3 engine outages were not likely caused by damage from the pad destruction. That's something that we're looking at. Okay, cool. So 3 engines out, but likely that was a conscious decision. Let's keep going. Now, why did SpaceX decide to do this? Surely they wouldn't have launched the rocket if they thought there was a high probability of the entire launch pad being destroyed. In fact, on numerous occasions, Elon and SpaceX defined success as the rocket taking off and not destroying the launch pad. Is that what happened? Well, probably some different opinions on exactly what the success rate there. That's why this is failed successfully, right? So yeah, even for all the memes, would they have pressed the big red button to launch this thing if they thought that it was going to destroy the pad? Probably not. Again, Elon said that based on their past experience, they didn't think the pad was going to get destroyed. They just thought that the concrete was going to be eroded. What does that mean? The power of the Raptors literally just scraping off, I guess it's not a scrape, blowing off, eroding away the top surface of the concrete. And, the longer you fire the Raptors at the concrete, the more the concrete erodes. And as long as the rate of erosion is not going to get all the way through the concrete, you think you're okay. You have a little maybe divot in the concrete where the Raptors sort of like blew the top off of it, but you didn't have any massive damage. Unfortunately, that's not what really happened here. The whole thing about concrete eroding assumes that the concrete remains structurally sound. It stays in one piece, basically. And as soon as you get a little crack in the armor, one little weakness in the concrete, and that rocket exhaust can get through that weakness and get under the concrete or between the concrete, everything you thought you knew about concrete eroded by rocket engines goes out the window. Looking at the angle over from the side, you can see the engine's lit. There's a big plume that comes off the side. And right here, this is where the engines are beginning to throttle up. They come in somewhere around 50%, like half power, and before the rocket takes off, they have to increase their thrust. You can actually see that happening. But at some point, while they're increasing their thrust, something underneath the rocket gave way. All of a sudden, look right here, you can actually see chunks of something coming up past the bottom of the rocket, flying out of the dust cloud. Not something you would normally want to have happen during a launch. And as it continues to go upwards, you can see chunks of concrete clearing the top of the tower. Not as big as a parking lot, but definitely sizes that you would not be happy with, say, if they, hit your minivan. Also, these pieces of concrete had to come from somewhere. It wasn't like SpaceX just, I don't know, left some extra concrete sitting around at the pad, and it was just going to get blown around during the launch. They cleaned the pad up. This is the FOD. We saw the sweepers and stuff going around so that there wasn't a lot of extra stuff to fly around. But the main structure of the pad needed to stay in place. That's what you're seeing flying into the air all around the pad. Not something they forgot. The pad itself being ripped to pieces by the power of the world's most powerful rocket. Yikes. The flying concrete's actually what inspired me to do the backyard test with the pressure washer. We're getting to it, stick around. But that's not the only interesting thing you can see from the first couple seconds of the flight. Look at this. You see when the rocket first starts to move? I've seen a couple rocket launches. Usually they go straight up. I mean, the shuttle had its twang and sort of took off because it had a thrust imbalance with the RS-25s firing this way, the SRBs firing this way. But the thrust on Starship was supposed to be symmetrical. Was it actually? Look at this. It does sort of a power slide off the pad. We've seen it sort of in some extreme examples, if you remember Astra's rocket launch, going out the gate. But in Starship's case, we expected it to go mostly straight up. Now remember, Elon said that the rocket took off missing a couple engines. Some engines were intentionally not lit, and maybe one or two of them were aborted, just not healthy enough, so they were shut down at liftoff. Whether or not this power slide was an intentional command programmed by the guidance programmers to get the rocket away from the tower, or a result of the engines being out and the rocket having a little bit of a thrust imbalance down at the bottom, that's a really interesting thing that we really need to look at. To demonstrate that, we're going to load up Kerbal Space Program 2. Real quick, if you don't know, KSP is a video game that uses realistic physics to simulate getting into space. You actually have to build your own rocket and put on engines and the right types of fuel and fly the correct trajectory to get to space. So we can use it to understand the forces acting on a rocket. Whoa, it's like I'm back on Twitch. Let's toss together a quick Starship. Okay, so here's our Starship on the launch pad. Game actually comes with a tower, doesn't have any chopsticks, but the flame diverter and the deluge system are free. All right, so remember, when we built the rocket, we put all the engines on the bottom symmetrically. There's 7, but they're evenly spaced around the bottom, so the force from the engines will be evenly distributed, right? Sort of equal in all directions. Let's see what happens when the rocket launches when all the engines are working. Here we go. 3, 2, 1. You press space in the game to make the rocket go. Anyways. But look at that. When it takes off, it goes pretty much straight up. All the forces are even, and the rocket's going pretty much straight up. A little bit of physics drift here, I think. But from there, I can use the thrust vectoring to turn the rocket in different directions. You can literally see the, air quotes, raptors pointing off to one side and sort of making the rocket rotate about its center of mass. But that is what Starship could do. All of the engines online, though, start you off with straight flight. Okay, cool. Good. Let's load it up again and see what happens if one of the engines doesn't work during liftoff. And I'm actually going to manually disable the engine after the rocket starts to go, just so we can see how this goes. So here we go. 3, 2, 1, space. Turning the engine off. And you can see the rocket almost immediately starts to lean over to the side and goes in a direction you, well, don't really want it to go. The VAB was a little further in that direction, so luckily we didn't get quite that far. But if one engine is out, creating a thrust imbalance on the bottom of the rocket, that's a problem. The rocket is going to encounter forces that sort of make it want to steer in a direction. So how did Starship keep that from happening? Aha. Let's go back one more time. Okay, same setup. This time I'm going to disable one of the engines on the bottom of the rocket, but I'm also going to turn on the guidance computer. And I'm going to let the guidance computer try to use the thrust vectoring to correct for the thrust imbalance that was causing it to flip over. Let's see what this launch looks like. 3, 2, 1, space. That looks almost exactly like what we saw in real life. And I'm not kidding you. Look at the bottom of the rocket. Even that looks very much like, engine count aside, what we saw on Starship. But with that one engine offline, it is definitely doing the power slide off the pad. Now, as the rocket continues to fly, we can continue this, and let's say we simulate another engine going out. You see it get a little bit of a twist, but you also see the engine sort of waggle at the bottom as the guidance computer uses the thrust vectoring, look at that, to try and overcome the tilt that's induced by the imbalanced thrust. Aha, but look at this. As we keep turning off engines, eventually we're going to end up with a situation that the thrust vector control is not enough to compensate for. And that's when you start to get motion like this. The rocket can no longer maintain its upward momentum and it starts to lean over sideways like this. So back to Elon's Twitter space, all right? When Elon was releasing all those juicy details about the launch in his Twitter space, he actually said that the slide of the rocket was caused by the engines that were out, which implies that it was not an intentional commanded maneuver. Well, big deal. At the end of the day, it worked out fine. Who cares? Well, check this out. Let's look at the bottom of the rocket and figure out which engines were actually offline. If you look at this photo from SpaceX, you can kind of clearly see 2 engines that were out by the time the rocket sort of was clearing the pad. When the telemetry on SpaceX's stream came up, it seemed to confirm that there were 3 engines that were out. And here's the positions. Now, if we try to spin all this around in our head and we look at SpaceX's telemetry and we try to match that up to the video, we see that these are the engines that look like they weren't online during the launch. You've got 1 engine in the center core that wasn't lit, this was engine 1, and 2 engines in the outer ring that weren't running. Maybe 26, 27, 28, like in that set. Okay, hold up. Elon didn't actually name those engines, or I guess number those engines in the space, but stick around for a little while and I'll explain why we think that those are the numbers that were not on when Starship lifted off. Check this out. On the pad, engine 27, 28 are in this direction. They're actually sort of, you know, if you put it on a clock, it would be about 1:30, 2 o'clock on a 12-hour clock, right? The graphic they showed is actually as if you were looking up at the engines from the bottom. But if we want to locate these on the pad looking down at a satellite view, we actually need to flip the SpaceX graphic over so that the engines match. That sort of puts the engines out on the outer rim in this direction. Now, it's not due north towards the tank farm, but it's not due east towards the ocean either. It looks like it could sort of be coming off here at an angle. So let's go over and compare that to what we observed in the videos. Honestly, the best angle to see this from is probably SpaceX's drone video that was out over the water, right? From here, you get this nice straight-on view of the rocket with the tower behind it. When the rocket first starts to move, you can see a little bit of tower on either side of it. Good, it's in the center of the tower. But watch, as the rocket starts to go up, the right side of the tower becomes obscured and you can see more of the left side of the tower. So we may need to look at it from a different angle to see this. But guidance computer's on. Let it use the thrust vector control to try and fix the thrust imbalance. 3, 2, 1, space. Engine deactivated. See the little lean. But we are very much getting the lean in the direction of the engine that's out. In fact, I bet you we could simulate that drone shot where we're looking at it from the end and we see it sort of drift over to one side of the tower. Of course, we're exaggerating it here because we have less engines, so one engine being out is a bigger effect, right? But it's amazing that it's just flying directly in the direction of the engine that's not working. Aha! So that seems to visually confirm that the rocket did in fact lean and slide in the direction of the engines that were out at liftoff. And luckily, the engines that were out were not straight towards the tank farm, straight to the south where it may have clipped a chopstick, and worst case scenario, on the side of the tower, which may have made the rocket actually hit the tower. Worst case, started leaning towards the village and flying in that direction? That's a big problem. So, it seems like it's confirmed. Elon said that the rocket sort of slid in the directions of the engines that were out. These are the engines that seem to identify as out from the diagram in the video, and the rocket went in sort of this direction, sort of to the northeast, out towards the ocean, a little bit towards the tank farm. Good, it cleared the tower and it was able to get away without causing, too much damage. Your mileage may vary on exact definitions there. But if that's the case, if the rocket went in that direction because of the engines that were out and not because it was a fully commanded pad avoidance maneuver, that's actually a little scary. Now, SpaceX are smart people. They've launched a few rockets in their time. I'd like to think that they made that conscious decision in their minds, right? Somebody's sitting there and, their engine health board shows that engine 27 and 28, they're not healthy, we're going to launch with them. All right, so with those engines out, the rocket's going to sort of like have less force in this direction. It's going to lean this way a little bit, and it's going to sort of slide off the launch pad in that direction. But it's okay because that direction is away from the chopsticks and away from the tower and away from the tank form and all those sorts of things, right? I'd like to believe that SpaceX actually consciously made that decision before they decided to let this thing go. Phew, all right, so we launched without a couple engines. Concrete flew everywhere, but it probably wasn't the problem with the first couple of engines. The rocket slid off the pad, but it didn't hit anything on the way out. But still, orbit wasn't in the cards for Starship that day. Back to the Twitter space to see what Elon said about this event.
Then at T plus 27 seconds, engine 19 lost communications, concurrent with some kind of energetic event that liberated the outer heat shield from the engines 17, 18, 19, and 20 area. You can see this on video, actually.
Some kind of energetic event that liberated the heat shield from the engines. Hang on. Let me translate for y'all. Something blew up. And Elon actually says that it's engine 19 that lost communications. So if we couple the engine losing communications first, engine 19, with the SpaceX graphic, and we mark this as engine 19 in the 17, 18, 19, 20 area, then we can also roll back, remember when we said 27, 28, that these engines up here would be 27 and 28. Now, if something truly did blow up, I mean, Elon said it may have caused damage to the other engines in that area. So let's watch the performance of those engines as we continue on. We get all the way up to T plus 29 seconds, and you see another engine go out. But this engine just doesn't not light and show up as a little, dark circle on the bottom of the rocket. This engine actually dies a fiery death with a huge plume of flames flying out the back of the rocket. And in fact, let's talk about that real quick. The normal methane flames coming out the bottom of the Super Heavy are nice and clean. It's sort of a clear flame. When something goes wrong and you get, let's just say, less than perfect combustion, plume's a lot more dirty. It turns yellow, it turns orange. You can really see the difference between the nominal clean flame of the Raptor and the flame of a Raptor rapidly exiting this world. But not in a good, we're exiting this world because we're going to space today. And it's not just the flames, it actually looks like there's some chunks of shielding that come out in this explosive event. Now, if the shielding is flying in different directions, did it impact another engine? Maybe so. Look at this. Shortly afterward, you start to see signs that the engine next to the one that just gave up is having trouble, and eventually it goes out as well. Is it just a coincidence that two engines right next to each other would go out at the same time? You got Raptors stuffed in there like clowns in a clown car. I think it's probably likely that an exploding Raptor may have some impact on its neighbors. And in fact, it's just not the engines nearby that may have taken some damage from it. Look above. You can see confetti coming out the sides of the rocket. Whatever sort of fireworks you're used to, orbital-class rockets usually don't throw confetti off the side. It looks like those failing engines may have also affected the HPU. What's an HPU? HPU stands for Hydraulic Power Unit. That's just above that position where we saw the failures. Some of the other systems on the rocket actually require hydraulic pressure, a lot like a crane or an excavator, to make things move inside the rocket. One of those is the thrust vector control, or the engine gimbaling on the Raptor engines, which is crucial to actually steering the rocket. So imagine you sat down in your car and you started to turn the steering wheel, but your car didn't turn. Losing a hydraulic power unit might have done that to the rocket. Now, Starship actually has two of these HPUs, one on either side. So just because one side turned into a rocket piñata and started showering forbidden candy all over the ocean doesn't mean that all is lost. It still had some steering control. Remember when I showed this in Kerbal? Now, in real life, if the HPU goes out, you lose access to that thrust vectoring. The hydraulic pressure isn't there to actually move the engines in different directions. In Kerbal, it didn't matter. The guidance computer could keep using the thrust vectoring to correct for the imbalance. In real life, if they lost one of those HPUs, that's almost more important than losing an engine. You've got 33 engines, you've only got 2 HPUs. How much steering authority did they lose if an HPU exploded? The Super Heavy booster wasn't done with its Raptor flameout extravaganza. As the flight proceeds, more Raptors start to fail. In fact, by T plus 1 minute and 10 seconds, you can see that there's a shot that shows that there are 6 engines out. In fact, SpaceX's own livestream telemetry doesn't seem to agree with this, because when we can clearly see 6 engines not lit, livestream telemetry shows 5. We have to be a little bit careful as to whether or not we trust that little screen graphic. Now, another interesting thing that we can see here is where the engines are out. Maybe it's just a coincidence, but the engines that are not online all seem to be on the same side of the rocket. Now, remember what we talked about earlier where we had the symmetric thrust to make the rocket fly straight, and how having asymmetric thrust, a couple engines out on one side, made the rocket sort of slide in a direction. As more engines fail, all on the same side, that makes the thrust imbalance get worse and worse. Now, that'll make you slide off the pad, but just because you're flying, that doesn't mean the problem goes away. Super Heavy could deal with that because remember, it has the thrust vector control. But that's driven by the HPU, and Starship's down in HPU at this point. That means that it likely has less capability to use the engine steering to correct for the engines that were out. Now, Elon mentioned this as well. He said that they probably should have throttled the other engines up. Why is that? When you're down a few engines and you're relying on thrust vector control to keep your rocket flying straight, if you have more force coming out of the engines that you can still aim, you have more control. Not only could throttling up have compensated for the loss in just forward thrust that Starship had because of the engines that were offline, it would have also given the thrust vector control more authority to impact the course of the rocket. More force coming out the backs means you have sort of more force to help you steer the rocket. But anyways, knowing everything that we've looked at so far, we can tell that Super Heavy and Starship are not having a great day. In fact, check this out. If we look a little bit closer at the bottom of the rocket, there seems to be some orange that's not normally there. That may indicate that there was a fire in the engine bay up around the guts of the engines. Usually fire comes out the back of the rocket. That's not that big of a deal. Hopefully it's a nice clean blue methane flame and not a dirty orange flame. But when we start seeing orange up in the engine cavities itself, yikes. Is this fire hurting other systems? I mean, remember, the Raptors are sort of isolated as much as you can when you have them crammed in there. There's the shields between them and that sort of stuff. But if a fire melts a electrical cable or something like that that's not shielded, you may continue to have cascading problems with your rocket. Here's another thing. If you've seen our launch broadcast, you know that we usually call out max Q. Max Q is the part of the flight where the forces acting on the rocket are, well, the greatest at maximum. You've got the force of the engines pushing on it. You've got the weight of the rocket pushing down on it. You've got the atmospheric density. You know, how dense is the atmosphere and how is the rocket flying through the air? Is it flying sideways? Is it flying straight through it? How thick is the air? How thin is the air? The point where all these things come together is known as max Q. It's important for rocket engineers to understand what that number is because, well, if your rocket can survive through max Q, you've done good. Now, here's the trick. SpaceX did call out max Q.
Max Q.
But as it turns out, during any flight, you're going to have a max Q. You're going to have a point in the graph where the forces are the greatest, even if it's not really the point that you were expecting or the force that you were expecting. I mean, I can walk out my front yard and throw a baseball, and my baseball is going to hit max Q at some point. Anyways, SpaceX called out max Q about 30 seconds later than what was anticipated, and clearly, with the number of engines out and the way the rocket was flying, maybe not exactly the Q they were anticipating. Speaking of flying, look at this. From here on out, you can see that the rocket is really struggling. It's starting to fly at an angle. I mean, look at the plumes coming out the side of it. You see the sort of the venting? Normally, if a rocket's going, straight up, those vents will go straight down the body of the rocket. If you see a vent coming off at an angle, that means that the rocket is not moving through the air in line with its own body. It's sort of flying through the air sideways, causing the plume to sort of come off at an angle. In fact, the angle of the plumes, the angle that it's flying through the atmosphere, seems to get greater and greater as it goes on in the flight. Around T plus 1 minute and 57 seconds, there's another huge flame that comes out the back end. And not the type of flame we want to see, the flame that seems to indicate that something else has gone wrong. If you go over to the SpaceX footage, you can see that the rocket's beginning to yaw. I mean, just look at the motion relative to the ground. It's not flying the way that you would hope for your rocket that's going to make it to space today should be flying. Once we get to almost 2.5 minutes, it's clear that the stack is seriously not flying right. I mean, just more and more orange flames coming out of the engine section. In fact, this is a point where I exclaimed,
"Did it just do a Kerbal?"
I mean, I've seen a few rocket launches, both in the real world and in Kerbal Space Program, and it didn't look right to me. I mean, it's all good and well when you do a flip for style on the way to orbit in KSP, but real rockets don't work that way. Now, here's another interesting thing. At some point on the webcast, the commentator claimed that the flip was intentional.
Beginning the flip for stage separation.
And I think there might have been a little scripting disconnect there. Because yes, we have heard that Starship and the Super Heavy booster are supposed to separate from each other by using a little bit of a flip to the booster to sort of free itself or free the ship from it. But I don't think that this was the flip that was actually planned. It may have been the case where the commentator was talking about a flip that was supposed to happen, and the rocket was actually flipping, but the flip that was flipping was not the flip that they had hoped for. All good, a rocket launch can be a very fluid situation, especially when things aren't going right. Speaking of following the script, at some point they also call out BECO. BECO usually stands for Booster Engine Cutoff.
Booster engine cutoff.
But we don't actually see it happen. In fact, it looks like the engines on the bottom of the Super Heavy booster continue burning and never shut down. I mean, look, we see this sort of plume interaction all the time whenever we see Falcon 9s do boost backs. That's a normal thing to see whenever a rocket is moving in a direction and firing its engines in a different direction. But this doesn't seem to be a boost back burn. I mean, remember, there wasn't a boost back burn actually planned for this first flight of Starship. It just looks like the rocket's out of control. I don't care what you think you could do or recover from in KSP, real rockets don't get to fly this way. I mean, the rocket is clearly deviating from the course. Not only is it not, going up towards space anymore, and we have to start thinking about the safety of the areas around the rocket. Now remember, they clear out a huge area just in case something like this happens. They have the marine hazard avoidance areas where there shouldn't be any boats or any people in floaties or anything like that for miles in every direction. And luckily, the rocket's still over that area. And before it gets out of that area, they're going to need to trigger the flight termination system. That's the FTS. If you've ever heard us say the FTS, they're working on the FTS. That is the system that's supposed to turn the rocket into rocket confetti and make it fall out of the sky. In fact, normally when an FTS system activates, it's an instantaneous thing. It wasn't immediately obvious when watching this launch live, but it may not have been very immediate for Starship. In fact, that's something Elon talked about on Twitter. He said that they initiated the flight termination system, but it took way too long to actually destroy the rocket. In fact, he said it may have been up to 40 seconds, and if you look at the video, it looks like it's actually closer to 50 seconds. So roll back the tape one more time and let's see if we can see the FTS going off. You know where the vents are normally happening from on the rocket as it sort of flounders its way towards space. But look at this. Right here on the ship, and then down here on the booster, you see new vents appear all of a sudden. It's almost as if something poked holes in the tanks. And in fact, that's exactly what a flight termination system tries to do. They usually put the flight termination system explosives near weak points of the rocket that'll cause a rupture, destroy domes or bulkheads, and make the rocket just become structurally unstable so that it falls apart. What they might not have accounted for is that Starship isn't built out of the lightest materials available in a clean room by rocket engineers. It's built by oil field welders using stainless steel out on the beach. Starship was a little bit more robust than they had anticipated. If these streamers are in fact the flight termination system poking holes in the tank, and it did actually take 40 or 50 seconds for the rocket to fall to pieces after that happened, that's not good. Well, you say, it was still in the hazard zone, no big deal, turned out okay. What if it had turned towards South Padre Island, 5 miles away where everybody was watching from? What if the engines towards the tower were out and it clipped the top of the tower on the way and sort of tilted over flying towards the village? 40 or 50 seconds is forever in the flight of a rocket. And if your flight termination system doesn't immediately stop the rocket from doing what it's doing and fall as close to ballistically down as possible, you gotta revisit that system. In fact, Elon said that that's probably going to be one of the longest polls, the longest lead times on the next flight, recertifying that when they tell the flight termination system to blow up the Starship, it blows up the Starship. Now, there's all sorts of other things that go into this, like the density of the atmosphere and the trajectory of the rocket and how much fuel there is left in the tanks when you do it, but none of it matters. The flight termination system has to terminate the flight. Not later, right now. I mean, in fact, as we were editing this video, we saw what seemed to be a flight termination system test over at Massey's, the old gun range where SpaceX does some pressure testing, cryo testing, maybe Raptor testing in the future. But there's the aftermath of this tank that actually had a little bit of flash on the side before it lost structural integrity, and that may very well be SpaceX already trying to pin down that FTS and get it recertified for the next launch attempt. And then finally, we get the double explosion that is the exclamation point punctuating the fact that Starship will not go to space today. So clearly Starship had some problems, cascading problems, during the flight. But why? I mean, we've seen hundreds of Raptor tests out at McGregor, and we don't observe anything like a 6 out of 30, 6 out of 33 failure rate out there. Now, to be fair, sometimes tests may get aborted and we don't actually see them start. We don't count those in the log, right? So the engines at the beginning that didn't start, maybe we can't count those. But the ones that failed in flight, we don't see that sort of rate in the tests at McGregor. I mean, based on what we can see, the Raptors are pretty reliable, even though SpaceX continues to iterate on them. Here's a clue in what SpaceX actually named the mission. They called it the Starship Integrated Test Flight. It's one thing to test a Raptor engine in a controlled environment, one at a time, on a test stand. It's a whole other thing to test 33 Raptor engines all jam-packed next to each other. It's also different to have the systems on the Starship feeding the fuel, doing all the telemetry, running the engines, giving them commands and that sort of stuff, than the test stand doing the same thing. That's why it's the integrated test flight. The engines are integrated into the rest of the Starship system. And that's a critical step of any rocket process, right? You're building a new rocket. At some point you can unit test, whatever you want to call it, all of your parts, but they don't do you any good if there's just a Raptor over here and a fuel tank over here, and it holds pressure and it makes fire. At some point, you need to put them together and make sure that they create a rocket that can take you to space. So maybe some of the stuff that happened here was an artifact of being plumbed into the rest of the systems on Starship, super heavy. Maybe Raptors being next to each other had some effect, but could it have been something else? So we know that SpaceX really wasn't in control of the energy coming out of the bottom of the rocket, and we know that things with the concrete, with the FONDAG, didn't really go as planned, and there was a failure, and concrete started flying everywhere. But the dust cloud that formed underneath the Starship made it so we really couldn't see what was going on inside. We saw pieces of concrete flying out the sides and all over the ocean and that sort of thing. But what happened to the launch pad in between the time that there was a nice, flat piece of concrete there and a huge smoking crater? I decided it was time for me to get off the computer and get to actual work to try and see if we could replicate the physics of what may have been happening inside that dust cloud. Check this out. I actually tried to create my own analog for the ground underneath the launch pad using some grout mixture and sand and gravel and some wooden frames in a cardboard box. I grabbed my trusty dusty pressure washer and fired them at the pad at point blank range just to see what would happen. And as it turns out, when you watch what happens when you dig a hole in the ground with a fluid flying at high velocity, there's some really interesting things to see. I mean, look at this. As long as the, air quotes, concrete held up underneath the pad, you could see how the energy is more dispersed. It sort of goes out in every direction. Every now and then, as you move the jet around, you can see some sort of like reverse jets form, but none of them seem to come straight up. When a jet forms, it seems to be going off to one side. Doesn't look like it will actually hit the rocket, or, the bottom of the pressure washer. Also, keep in mind, I didn't have a miniature orbital launch mount here, which has the huge sort of floor that would also protect the bottom of the rocket, especially as it starts to get away. So maybe I need to build one of those. Leave a reply down in the comments below so I can show my wife and be like, no, look, I have to do this. Please, YouTube told me to. I don't think she heard that. But look at this. As soon as the concrete pad fails and you have sort of a dome in the ground, everything changes. You can see it digging up the dirt and the sand and the rocks from underneath the concrete and flinging things in every direction. It almost looks like in some cases it magnifies it, almost like a dish that's reflecting it back up. Maybe that explains how the pieces of concrete got flung past the top of the tower, chasing the rocket into the sky. Here's another thing that happened. As I start to simulate the rocket taking off, like the source of the pressure moving away from the pad, at some point the pad cracks. It's obvious that the surface of the concrete had become pressurized, or where there's some amount of force pushing back up on the bottom of the concrete. Now, in this case, we just see the grout sort of crack. We don't see pieces of it actually get broken off and flung into the air, but something's happening here. And I've got two theories about what I'm seeing. First thing may be the fact that we're dealing with water. Now, water is not compressible, and if we were to fill the container with water and seal the edges of the container, at some point we can't fit any more water in there. Where before I had sand and gravel, there was a little bit of air space in there, and it's easier for the air to get out than the water to get out. So if the underneath of my pad got pressurized because it got filled with water, that may explain why it sort of jumps up all of a sudden. Another theory that I have, sort of looking at this, is it seems to happen when the nozzle of the pressure washer moves away. So I'm looking at this and I'm thinking, all right, maybe when I'm close to the pad, the very fine stream, it's not laminar, but it's still in a very fine stream, is contained in a small volume and allowing room around it for air to evacuate out the hole. Right? So, a little thin stream goes into the hole, there's room around the hole for air to come back out, so that you don't get like the glub, glub, glub if you try to pour something out of a container and you don't leave an air hole, right? But as you pull away the fluid, in this case the pressure washer water, rocket exhaust also a fluid, right? But the fluid starts to, I'm going to guess, move air with it as well. And so you've got sort of more volume pushing into that hole and not really leaving any place for pressure to come back out. You can see it bubbling around the edges and sort of spurting around the edges where I sort of tried to seal it. But if that's what's going on, maybe both of those things are specific to using water here. But in any event, it doesn't change the fact that we can observe right here that if we have pressure acting on the bottom of the concrete/grout slab, that it can actually crack it in an upwards direction, and that would explain how slabs of concrete went up instead of down. All goes back to that as soon as there's a weakness and you can pressurize the softer area, the soil, the sand, whatever, that's underneath the concrete slab that you pour, all of a sudden you have forces going in a direction you didn't intend coming up from the bottom instead of down from the top. Maybe that's why we saw that. And there's even more interesting stuff that I observed in the backyard test that I've never really thought about. Look at this. As long as the pressure source, the nozzle, is down near the hole, things are sort of coming straight back out of the hole, right? It's almost like the area around the hole is sort of protected by the fact that there's a hole there, serving as sort of a rim to deflect more of the energy upwards instead of sidewards. But as the rocket pressure washer lifts off the pad, look at what happens. The force is no longer all concentrated in the hole, and it starts to spread out. You can actually see some of the larger gravel chunks roll away sidewards instead of upwards. I wonder if the same thing happened with Starship. We saw some things out there in sort of the, desolate wasteland. That's not it. The sandy area where there's now a piece of concrete in the sandy area. But we saw some places where it looked like things were moving sidewards along the ground. Now, did they fly ballistically through the air and then roll or skid or something like that? Or was there a force being exerted on them sideways so they sort of slid sideways? I don't know. But look at this. When the pressure washer nozzle gets further away from the pad, it allows the force to spread out even more. And when that happens, you get this very clear transition where things start to go sidewards instead of up. Even if that's not what happened on the actual Starship launch pad, it's really interesting to look out and just observe the clear visual difference as the rocket takes off. It's gratuitous use of air quotes in this section. Now, I get it. It's a very rough contraption. I mean, it's not to scale and I didn't even have time to paint it. But I do think that there's some interesting things you can see from the interactions here. I wasn't dealing with heat or energy, and I clearly don't have access to a bunch of Raptor engines. I mean, heck, I chose the grout mix because I figured that the pressure washer could erode the grout mix. I didn't want to sit there for 20 minutes trying to dig a hole in a piece of actual concrete with a pressure washer. But it's clear that there's a big difference between just impacting the concrete and dispersing and the concrete failing and actually causing things to be reflected back up at the bottom of the rocket. Does that mean that Raptors may have taken some damage from a piece of concrete or debris flying up at them? I can't tell you, it's a pressure washer in my backyard. But I do think that it's plausible that the higher than expected failure rate of the Raptors during the integrated test flight may be explained, potentially partially, by damage from the pad flinging pieces of concrete at the bottom of the rocket. Wacky roadside rocket science aside, it's clear that SpaceX knows they're going to have to do something about the rock tornado that formed underneath the rocket. In fact, Elon mentioned in the space that they were working on a upside-down shower head, sort of a steel plate with a cavity in the middle that they could fill with water, drill a bunch of holes, and then sort of spray water up as the exhaust from the rocket comes down. It's a hybrid sort of deluge system, different than anything we've really seen before. I mean, we've seen Rainbird sort of put gushes of water in from the side, but I'm not aware of a pad that actually has the deluge system coming up from the bottom like some sort of weird Las Vegas water feature. And there's another part of the video where the comments are going to be like, actually, Dosh, the Delta II had an upwards... Hey, have at it. I love to learn things. Is it going to work? Elon said it wasn't quite ready for this launch, but you know that they're working on it right now, and I imagine we'll see parts added underneath the OLM long before anything tries to go to space again. And actually, breaking news, as we were about to release this video, SpaceX tweeted a test from McGregor where they were firing a Raptor engine at a plate that had water coming out of it. So if you had questions about whether or not a rocket engine firing at a hole in a steel plate would overcome the force of the water coming out, SpaceX is way ahead of you. So anyways, to tie all this back together, that's why the theme of this video is Flight Failed Successfully. Even though Starship clearly didn't come anywhere near its goal of going all the way around the Earth and splashing down near Hawaii, and if they missed their goal by that far, what could they possibly have learned that was worthwhile? Back to the Twitter space. Admittedly leading with all the positive stuff, Elon said that they got a lot of good data about autogenous pressurization. What the heck is that? All right, you have to keep pressure in the rocket fuel tanks, right? And some rockets, like Falcon 9, use helium to use that. And, okay, you can buy balloons at the supermarket or whatever, but actually, on an industrial scale, helium's pretty rare, and it gets to be a little bit expensive when you're using lots of it. So, if you're building a new system that you expect to fly a lot, it makes sense to pressurize the tanks another way. Enter autogenous pressurization. That's actually trying to keep the tanks pressurized with the gaseous form of what's already in them. You've got liquid methane, liquid oxygen in the tanks, make that a gas, put it into the top of the tank, and use that to keep the pressure. Excellent. Said they got some great data on that. He also says that Starship went supersonic. That was apparently no problem at all. I mean, remember when we talked about Max Q? If you can break through the sound barrier, you get a little bit of a shock that happens whenever you're punching through the sound barrier. And so there are some specific forces that act on the rocket. Making it through the sound barrier, another important thing to be able to gather data on, and they did it in this flight. Yet another thing, to actually a round of laughter, Elon said that the structural margins were better than expected. Remember when we talked about the flight termination system not terminating the flight as quickly as it should? Certainly looking for the silver lining in that cloud of concrete dust, but it's true. Structural margins on Starship exceeded what they expected. And finally, they definitely learned whether or not their hypothesis about eroding concrete with Raptor exhaust was true or false. Concrete didn't just erode, it broke, and they know that they have to fix that. So it is experimental data, it is valid, it is true that something has to be done because it's not as easy as they had hoped. So even though the destruction of the concrete underneath the pad looks like pandemonium, it actually validated something they needed to know. They can't get away with just a flat concrete pad, and they're already putting effort into mitigating that energy. So here come the armchair rocket engineers again. He should have known better. They should have simulated it. They should have taken longer or been more careful or had larger margins or whatever. I don't know where you've been, but SpaceX doesn't work that way. They want fuel in the tanks, flames in the engines, and rockets in the air, and that's how they get the data that supports their rapid iteration. Now, they have to do it safely, and the flight termination system is a big deal. Even if you're trying to rapidly iterate, even if you're trying to colonize the moon and Mars, you still have to get us there safely, and there are definitely some discussions that need to be happening there. Anyways, I had a ton of fun making this video. I learned something, which is always a good day. Maybe you agree with me, maybe you disagree with me. I'm sure you're going to let me know down in the comments. Whether the next flight is 6 weeks or 6 months away, kick back, put on your favorite merch from shop.nasaspaceflight.com depicting a piece of concrete hitting a vehicle. Maybe catch up with me in Pixel Starships and see if you can be a flight termination system for my Starship. Or maybe just watch our next This Week in Spaceflight or the latest Starbase update over this way. We're able to keep leveling up our coverage, our content, our videos we make because y'all keep showing up. So however you slice it, thank you for making this possible. I'm John Galloway with NSF, and I'll see you nerds later.